This curve sketching exercise 511, sketch the following function. Y equals x squared over x squared minus 9. All right. All right. Whenever we sketch functions, it's a really good idea. Well, you have to know x-intercepts, y-intercepts. That's first. So let's do, I think we should do y-intercept first. Let's work out the y-intercept. So these are our steps, always. Y-intercept. How do you find y-intercept? Substitute x is 0. So what do I get here? That y is 0 squared over 0 squared minus 9, which is 0 over negative 9 is 0. So that's my y-intercept, 0. Let's find, if the y-intercept is 0, look, that's the x-intercept as well. When x is 0, y is 0. When y is 0, x is 0. You got it? So when x is 0, y is 0, the curve goes through the origin. Do you get it? So that means that the curve passes through. We know that when x is 0, y is 0, it passes through 0, 0. That's one point on the graph that we know. Okay. There's going to be no... Now, number 2. Have a look at the denominator. Tell me something. Very good. We know that x squared minus 9 can't equal 0. This is telling me vertical asymptotes. So, by looking at the denominator, when you look at the denominator and you see the values of x that you can't have, you know that restricts your domain, you end up with vertical asymptotes like dotted lines down your graph, all right? So vertical asymptotes, we know that x squared minus 9 cannot equal 0. What are you going to do here? You can factorize, or you can put x squared is 9. But if you do x squared can't equal 9, you must then say that x cannot equal plus or minus 3. So we've got 2 vertical asymptotes, one at negative 3, one at positive 3. I'm going to start sketching just over here, but not the proper sketch. This is what I've got so far. 3, negative 3. And I know my curve passes through 0, 0. Okay, now what I do, I need to do a few more things. I know that I've got an asymptote there at 3. I know I've got an asymptote there at negative 3. All right, we're going to do something. All right, we're going to look at the behavior of the curve. I'm just going to go on this side. I'm wondering where the curve is at the point just before 3. So all you do is you substitute. So we're going to look at the curve around the asymptotes. So now that I know that there's an asymptote here, I want to know either the curve's going to be up there, girls, or it's going to be down here. That's what happens to near asymptotes. Your curve approaches it but never reaches it. So I'm going to substitute. So I'm looking at the behavior near the asymptotes. The behavior of the curve near the asymptotes. So what I'm going to do, I'm going to substitute just before x equals 3. I'm going to substitute x is 2.9 or 2.99 if you want to be even more accurate. What do you want to do? We can just do 2.9. That should be good enough. Let's substitute x is 2.9 into the original function, into x squared over x squared minus 9. So substitute that into y equals x squared over x squared minus 9. And what do you get? 2.9 squared over 2.9 squared minus 9. What do you get? Negative 14. Doesn't have to be exact. That'll do. So when x is 2.9, y is negative 14. In other words, it's down here. Now this is an asymptote, so your curve will go like this. You know your curve passed through 0, 0. When x is 2.9, it's negative 14. It won't go like, if it goes this way, if it curves this way, it's going to hit the asymptote. Do you get it? It's approaching the asymptote but never touches it. All right, negative 14 I know is all the way down here, all right? But that's probably, do you get that? You can't go this way. You'll cut it if you do. You have to approach the line x is 3 but never touch it. All right, let's look at the other side when x is 3.1. So we're looking at the left-hand side of the asymptote, 2.9. When x is 2.9, where is the curve? It's either going to be positive or negative. Is it up here or down there? If I got a positive answer, I would have drawn it up like that. All right, let's look at x is 3.1, substitute it into the curve. I get y is 3.1 squared over 3.1 squared minus 9. And what do I get? Well, it's either going to be negative or positive. I'm getting 15.7. So it's up here. Do you get it? When x is 3.1, I've got 15. It's up there. Now, I need to know the rest of the story along here. Now, you know how you were just doing as x approaches infinity? This is where this comes in. All right, so I know it passes through 0, 0. I know when x is 2.9, it's negative 14. If x is 2.99, it'll probably be negative 100 or something like that. When x is 3.1, I'm getting 15.7. It's up there. Now, I just need to know as x approaches infinity. Yes, you can do what we did earlier, the limit as x approaches infinity. But you know what I prefer to do? Substitute x is 100, or x is 10, or x is 50. It's easier. You know why? It'll let you know if you're coming from above or below. Look, we will do the next bit. We'll do it anyway, both ways. We're looking for horizontal asymptotes. So, in question, horizontal asymptotes. Parts 2 and 3 are really the same. You know, I haven't done negative 3 on purpose. I'll tell you why in a minute, all right? I could do the same for negative 3 and substitute, but I have a quick way of getting around that. So really, parts 2 and 3 are really just part 2. I'm just looking at vertical asymptotes. I know that there's an asymptote at 3, and by substituting, I can tell where the curve is around that point. Is it up? Is it approaching it from up there, or from this side, or from down there, or does it go like that? Now, horizontal asymptotes are these ones. What happens as x approaches infinity? So, as x approaches infinity, you can do the limit as x approaches infinity, but I just substitute a big value. What do you want to substitute? X is what? 100? I'm going to go sub x is 100 into the equation. I've got y is 100 squared over 100 squared minus 9. We're going to do this two ways. .00 whatever. 9. It's approaching 1.0009. Isn't it therefore as x approaches infinity, what do you think y approaches? What is it approaching? 1.0009. 1. From above. Now, if you can't see that, I'm going to do the limit. 1.0009 is approaching 1, girls, not 2. It's approaching 1. It's almost 1. But look, what we'll do instead, for horizontal asymptotes, someone told me 1.00009. That's approaching 1. So, or you can do the following. For horizontal asymptotes, you find the limit, if you want to do it this way, as x approaches infinity, which is what we were doing before, of x squared over x squared minus 9. You can do it this way, what we were just doing. So, the limit as x approaches infinity, how do I do that? Equals the limit as x approaches infinity. Don't I divide by what? X squared. What do I get if I divide the top one? I get 1. So I'm going to divide by x squared. Divide through by x squared. I'm just going to put it here. 1 over x squared on x squared is 1 minus 9 over x squared. Are we okay with that? I sort of jumped a step. Are we okay with that? Divide by x squared, divide by x squared, divide by x squared. What do you get? 1 over 1 minus 0, which is 1. Now that gives you your 1 if you do it this way, but this tells you which side when you substitute. Yeah, it's approaching 1, but am I coming from 0.9999? That would be from below. If I was 0.999, yeah, that's approaching 1 from below, but this is 1.000, that's from above. Now, if you want, 100 might be a bit too extreme. You could have done 50, you could have done 10. All right? So I know it approaches 1, but because of my substitution, it's approaching 1. So I need to put an asymptote, another one. Not 0. So I've got the asymptote there. Are we okay with that? So as x gets really big, my graph approaches 1 from the top. So if you try x is 10, you'd be doing 100 over 91, which is 1.0 something. If I substituted x is 10 instead, I wouldn't get something so tiny. I'd be putting 100 over 91. What do you get for 100 over 91? What's 100 divided by 91, girls? 1.09? Yeah. Can you see that approaches 1 from above, 1.09? All right, now, I have to do this side. But before I do that, I'm going to look at my function. Do you remember how we did odd and even functions? This is all x squared. There's a good chance that this is an even function. So let's test. If it's even, do I need to substitute here, there, and everywhere else? Or do I just say the left-hand side of the graph is the mirror image of the right-hand side? Do you get? Even functions have symmetry about the y-axis. So I'm thinking, whenever you see x squared, think, wait a sec, and only even powers, I think this might be an even function. Let's check. So is it odd or even? So function of x is x squared over x squared minus 9. Let's look at the function of negative x. Well, you can see what you're going to get. Negative x squared over negative x squared minus 9. What do you get? The same? You get the same. So therefore, it's an even function because the function of x equals the function of negative x. Do you remember the rule for that? In other words, thank goodness, I don't have to substitute in negative 2.9, I don't have to substitute in negative 3.1, and I don't have to substitute in negative 10 or negative 100. I can just go back up to my drawing. Even function, therefore it's symmetrical about the y-axis. Do you see why we checked for that? So it might be a good thing to do earlier, check if it's odd or even, because then you only have to work on half the graph. But if it's not odd or even, you've got to do the full graph. So what do? Do I go up or down here? Down. And here I go there. Now let's just double check anyway. So all I did, I finished the rest of the graph off. Now what I want you to do, we're just going to check that this is correct. So let's check. I want you to substitute x is negative 2.9. I want you to substitute x is negative 3.1, and I want you to substitute x is negative 10. So, into the formula. Please be careful. Wait, actually, without even substituting, let's just have a look. If you put negative 2.9 in brackets and square it over negative 2.9 in brackets squared minus 9, won't you get negative 14? Same answer. When you substitute negative 3.1, and it's in brackets and it's squared, won't you get the same answer? And when you substitute negative 100 or negative 10, you're going to get the same answer. Because it's squared, and negative squared is a positive. You get y is 1.000, whatever it was, 9. Same answers. It's even. Now, how do you know it's going to be even? Have a quick look at the function. And just think if you substituted in the negative or the positive values, you'd get the same answers. But once you throw in a straight x or an x cubed, forget it. It's not going to be even anymore. If they're all even powers, only even powers, it'll be even. All right? That's our first one done. All right? Question 5a, sketch this. Y equals 1 over x squared plus 1. All right, let's do y-intercept first. Y-intercept. All right, put x is 0. When x is 0, y is 1 over 0 squared plus 1, which is 1. Now, let's look for, if I put y is 0, so, because I didn't get 0, I'm going to check for y-intercept, x-intercept, sorry. X-intercepts. Put y is 0. 0 equals 1 over x squared plus 1. Can you ever get 0? No, that has no solution. There's no x-intercepts. No. You swap those, you're not allowed to do 1 divided by 0. Or 1 divided by something will never give you 0. The bottom can't be 0. It's not allowed to be 0, and it can never be 0 anyway, because you'd have to have x squared is -1, which you can't get. And you're not allowed to divide by 0 anyway. The only way that the right-hand side is going to equal 0 is if the numerator was 0. That's got no solution. You will never ever get 0. X squared can't equal -1. A squared is always positive. You'll never get 0, but you're not allowed to divide by 0 anyway. If I swap across the diagonal, I'm not allowed to do it. I'm not allowed. You're not allowed to divide by 0. There are no x-intercepts. So all we know so far is that when x is 0, y is 1. All right, let's look for vertical asymptotes. Actually, I'll call that 1, x and y intercepts. Number 2, vertical asymptotes. Vertical asymptotes come from the denominator, looking at the denominator. So, x squared plus 1, I know can't equal 0, or I'm looking for when it equals 0. Is there a solution to that? Do I ever get x squared plus 1 is 0? No, that's got no solution. There are no vertical asymptotes. Look, vertical asymptotes are when there are x values not allowed. You have those dotted lines, horizontal, vertical asymptotes going down. The reason is the domain is all real x. If the domain is all real x, all values of x are allowed. There are no breaks. There are no dotted lines going down. So, you know, x squared is -1. That has no solution. So there are no vertical asymptotes. All right, well, that's good. This one might not be too hard. You know, I forgot to do odd and even. You have a quick look at it. You tell me what you think, if it's going to be even. So, no vertical asymptotes. Let's just look at the type of function. Is it odd or even? All right. So, we've got the function of x equals 1 over x squared plus 1. And the function of negative x is, we can see it's already going to be the same. Negative x squared plus 1, which is 1 over x squared plus 1. So, therefore, it's an even function, as the function of x equals the function of negative x. And you say, great, I only need to sketch half of it and copy one side to the other. Now, let's look at what I've got so far. I know that when x is 0, y is 1. That's my y-intercept. I have no vertical asymptotes. I don't have any dotted lines going down. I have no vertical asymptotes. I just need to see, my next step is horizontal asymptotes. I know that that I have no x-intercepts as well. So the graph's either going to go up there somewhere or it's going to come down here. All right, now let's have a look. Let's look for horizontal asymptotes. Now we can do it two ways. The formal method, the limit as x approaches infinity. So limit as x approaches infinity of 1 over x squared plus 1 equals, what am I supposed to do? Divide through by the highest power of the denominator, which is the limit as x approaches infinity of what? 1 over x squared over, we're dividing by x squared, all right? What do you get? 1 plus 1 on x squared, which equals, you okay with that? I've divided each term by x squared. So now when I substitute in x is infinity, I get 0 over 1 plus 0, which is allowed, which is 0. In other words, as x gets really big, this function approaches 0. But you want to see which side? It's more than likely going to come from above, more than likely. But don't always assume it will, because some curves, well, it will, because it never touches the x-axis. But let's just do it by substitution. Let's just substitute x is 10. We're not going to go so big this time. When x gets big, what happens to this curve? Y is 1 over 10 squared plus 1. It's 1 over 101, which is 0.0 something. It's either 0.01 or 0.099 something. 0.0099. All right. It's approaching 0. That's very close to 0. Is it above 0? If it was below 0, it'd be negative. So, the problem here, but is you don't know if it goes like this or if it's rounded. Now, you don't know enough at the moment to know that, because you haven't learnt about inflections. You haven't learned how to differentiate, okay? I think it is a bit rounded, but you aren't expected to know that. I don't think it can't go, it's either going to go, yeah, it'll go like this and down. Because if I go straight down, it's going to hit. I can't go down like that, it'll hit it. I don't think that this curve has a sharp point. You know, like, I've got two options here. Am I going to go down like that? Or am I going to go, just watching here, more like this? Sorry, like more rounded. Do you know what I mean? More rounded. The only way you could sort of know is maybe with a bit of substitution, whether it drops off sharply or not. Do you get what I'm saying? So if you put, for example, when x is 1, you get a half. When x is 1, it's a half. Maybe when x is 2, it's a fifth. When x is a half, what you get? You'll know if it's sort of dropping down or rounding. Look, but you don't have to know yet. Remember, this is a 2-year course. You won't be asked this question until the HSC, right? I don't mind if you draw it like that or if you do it a bit rounded like that. It's just that you haven't learned how to differentiate and know the shape of the curve yet. All right? So we're just going to do it a bit rounded at the moment. All right? So the other side's the same because it's even. So it's like that. The only way you could sort of get that shape at the moment is by doing a few substitutions near x is 0. Sketch the following. Y equals x over x plus 1. When you look at that, do you understand that you can't sketch it? How do I know that this is a 3-unit one to sketch as opposed to a 2-unit? If that x wasn't there and if it was just a number, like 1 over x plus 1, that's 2-unit. 1 over x plus 1 would be a hyperbola shifted 1 unit to the right. But once you've got an x on that numerator and denominator, it becomes 3-unit, okay? This won't be in the 2-unit paper anyway. It'll only be in the 3-unit paper. So, what do I do first? Remember, if we can do x-intercepts, y-intercepts, let's see if it's even or odd. So look, I'm going to write up here. So we want, basically, x-intercept, y-intercept. Then we want, is it even, odd, or neither? And then we want vertical asymptotes and horizontal asymptote. And that's it. They're the 4 things that we're going to be doing. Every time you get one of these, x or y-intercept or both, is it even, odd, or neither? Does it have vertical asymptotes? And if it does, you're going to have to look at the shape of the curve, x or y-intercept. So, for x-intercept, put y-intercept. So y-intercept, put x is 0. What have we got? Y is 0 over 0 plus 1, which is 0. You don't have to do y-intercept, you got it. Got it? When x is 0, y is 0. When y is 0, x is 0. So we know that 0, 0 is a point on the graph. Number 2, let's look for even or odd function. So function of x is x over x plus 1. Function of negative x is negative x over negative x plus 1. Do you think it's even? So function of x is not equal to function of negative x, so it's not even. Let's keep going. What do we do next? Negative function of x is, be very careful here. It's just negative in front of the whole thing, or you put a negative on the numerator or a negative on the denominator. So I'm going to put it on the numerator. It's negative x over x plus 1. Because it just goes in one spot, not 2 spots. Negative over negative is a positive. It's negative in front of the function. So I can write it as negative x over x plus 1. But then I decide, do I put that negative on the numerator or the denominator? I'll put it on the numerator. Do you remember I used to do this before? I used to say, right, negative a half. See how it's in the middle? Is real either negative 1 over 2 or 1 over negative 2. Remember that? Yeah. You can't put a negative on a negative, you'll get a positive. So, girls, do you think any of those 3 are the same? No. So, also function of x does not equal negative function of x, so it's not odd either. It's neither even nor odd. So forget all the symmetries. You have to do the whole graph. Well, maybe the graph's not that bad anyway. Well, the graph isn't that bad because you've only got one asymptote. If the graph's got two asymptotes, yeah, you've got a bit more work. There's only one asymptote, and where is that? So now we're doing vertical asymptotes. Vertical asymptote is look at the denominator. Girls, are we okay that vertical asymptotes are looking at the denominator? So, x plus 1, I know can't equal 0. It doesn't matter if you write equals 0 or can't equal 0. If I put x plus 1 is 0, it means that x is negative 1 is the asymptote. Or I can just go x plus 1 can't equal 0, x can't equal negative 1. Either way, it's the same thing. Therefore, we've got a vertical asymptote at x equals negative 1. Now I can start to build my graph. All right, I know that I've got 0, 0. It's not even or odd. And I've just got one vertical asymptote. So you only have to do a few substitutions now. So we start sketching. I know that the graph passes through 0, 0. And I've got a vertical asymptote at negative 1. What do you think I should do next to know what's happening? Yeah, we could, but I need to know where is the curve around this vertical asymptote. So I need to substitute values first. You okay with that? Got to substitute values first. Yeah, I know there's a dotted line, but is the curve up there or is it down there? Is the curve up there or is it down there? Whenever you've got an asymptote, the curve's going to be approaching it either from the top or down below. The curves definitely passes through here. Does the curve go up like that or does it go down here? That's what we need to know. So, what are we going to substitute? X is what? That's on, no, you just go negative 0.9, that'll do. Negative 0.9 is on this side, so you get y is negative 0.9 over negative 0.9 plus 1. Now, girls, 1 minus 0.9, that's positive 0.1. It's negative 0.9 over positive 0.1. Well, that's a negative. Is it negative 9? I think it's, work it out. Negative 9. So I'm going to draw the curve in a different colour. When x is negative 0.9, which is before negative 0.1, it's down here. Are you okay with that? And it goes through 0, 0. Are we okay with this? It can't go the other way. It'll hit the curve. It approaches it. Now, I know I'm going to have to work out what happens here. All right, what else should I substitute? X is what? No, let's do the always on the asymptote on the left and on the right of it. Negative 1.1. So, girls, I want either side of the asymptote. In this section, we're looking for the asymptotes and where is the curve on either side of it. I know the curve doesn't go through there, but where is the curve? So we've got y is negative 1.1 over negative 1.1 plus 1. That's negative 1.1 over what? Negative 0.1. That's positive again. Positive 11. So when x is negative 1.1, which is here, the curve is up there. Are you okay with that? What do you think I need to do now? I need to work out what's happening here and what's happening over here. Yeah, okay with that? Well, I know the curve goes like that, but how far down? I don't know. So let's do horizontal asymptote. Horizontal asymptote. Now you can do limit as x approaches infinity if you want the value, and then we can substitute to see if it's coming from above or below. So the limit as x approaches infinity of x over x plus 1. What would I divide through by? Divide by x, and what do you get? 1 over 1 plus 1 on x, and when I substitute, what do I get? 1 over 1 plus 0, which is 1. Now, the horizontal, in other words, as x gets very large, my curve approaches 1. But I don't know where it's approaching 1 from. So I need to put in the asymptote, right? And I'm going to draw it in. It's up here, 1. But, girls, I don't know if it's approaching from above on this one, below on this one, where it's going to. So, you can only work that out as if you substitute values now. I know it's 1. But, all right, which side do you want to do first? Let's do negative 10. Sub x is negative 10. I get y is negative 10 over negative 10 plus 1. Isn't that negative 10 over negative 9? Yes? Which is what? 1.11, etc. Yeah, it approaches 1, but is it coming from above 1 or below 1? Above. There you go. All right. You okay with that? If that's the line y equals 1, 1.1 is above 1. Right. Now, let's substitute x is 10, and we're thinking this one should come from below. We're thinking. But if it comes from above, it means it crosses it and comes back down. But I think it is from below. So you get y is, when x is 10, you get 10 over 10 plus 1. That's 10 over 11, which is 0.909. Well, that's below 1, isn't it? So that one's okay. It comes from below. Got it? Okay. It really does look like, yeah, but it's in the wrong quadrants. Do you notice? The x. If it was 1 over x plus 1, it would be quadrants 1 and 3. It's actually in quadrants 2 and 4 because of that x. Now, it's not odd because it doesn't have point symmetry about the origin. It sort of has symmetry maybe about here, but not about the origin. All right? How are we? Good? Sketch this. All right. When you look at it immediately, you can see something. This 1 plus means that the whole curve is shifted up 1. Now, provided this doesn't have an asymptote at 1 already, you know how the other one had an asymptote at 1? It could be shifted up 2 for all we know. We don't know. So don't assume the horizontal asymptote is going to be at 1. It may be, it may not be, depending what this function looks like. All right, what should we do first? Remember, x, y intercepts, is it odd, is it even? You can tell it's not even. Can you see it's not? It's not, right? So let's do y-intercept. Let's put x is 0. And what do you get? Y is 1 plus 0 over 0 squared is 0 plus 1. What do you get? 1. Now, I don't think I want to put, if I put y is 0, oh look, we could try, but we could. Let's try it. X-intercept, put y is 0. You get 0 is 1 plus x over x squared plus 1. What do you think I should do? Take the 1, yep. Negative 1 equals x over x squared plus 1. You know what to do now? Cross multiply. Negative 1 times x squared. So it's negative x squared minus 1 equals x. I don't think we really need this. Look, and then take everything over again. You get x squared plus x plus 1 is 0. That actually has, it could be a third, or it's got no solution. Two numbers that multiply to give 1 but add up to give 1? No, no such number. I'm just going to leave that one for a moment. What two numbers multiply to give 1 but add up to give 1? No solution. And if I do the discriminant, it's negative. So I'm just going to leave that for now. Let's see if it's even or odd. By looking at it, it does not look like it's either. But let's just do quick substitutions of function of negative x. Function of negative x would be 1 plus negative x over negative x squared plus 1, which is 1, which would be plus minus. I'd get 1 plus negative x over x squared plus 1, or 1 minus x over x squared plus 1. Are we okay with that? Because this is, denominator is x squared plus 1, then I've got plus negative. Plus negative is minus. Those two are not the same. And the negative function of x, this is not going to be odd either, would be negative of all of this. It's negative 1 minus x over x squared plus 1. Do you get that it would be the negative bracket of all of this? They're not equal. None of them are equal. So it's neither even nor odd. Why? Because the function of x does not equal the function of negative x. And the function of negative x does not equal the negative function of x. Look, when you've got a combination of squared and x, it's not going to be either, pretty much. Okay? So not even, not odd. Guys, look at the denominator. Let's look for vertical asymptotes. That's dependent on the denominator. All right, have a look at your function. Here it is. Y equals 1 plus x over x squared plus 1. X squared plus 1 can't equal, well, can it ever equal 0? It can't. So there's no solution. No solution to if I put it equal 0. Do you get it? If I put it equal to 0, where is that equal to 0? Because wherever that is equal to 0 is not allowed. That's never going to equal 0. Because when I rearrange, I get x squared is negative 1. That's got no solution. No vertical asymptotes. Aren't we lucky? So what do I have? I've got, so far, it's not even, it's not odd, and the y-intercept is 1. That's all I know. Not even, not odd, y-intercept is 1. Let's look for horizontal asymptotes. Plus 1. I don't go dividing the 1 by x squared. Just keep that. It's the fraction bit that you deal with. Now, what do I divide each term in the fraction by? Yeah, the highest power of the denominator. X on x squared is 1 on x. X squared on x squared is 1. 1 on x squared is 1 on x squared. Now we substitute. 1 plus, what do you get? 1 plus 0 over 1 plus 0. It's just 1 plus 0. 1. We have a horizontal asymptote at 1. This is what we've got. Y-intercept is 1. Goodness me. Horizontal asymptote is 1. How weird. We've got to see what we're going to do. So it actually cuts through here, but the horizontal asymptote is 1. Seems strange. We've got a horizontal asymptote at y is 1, but the y-intercept is 1. Asymptotes are only asymptotes for very large and small values. So we come back down and we do some substitution. When x is 10, y is 1 plus 10 over 10 squared is 100 plus 1 over 101. What do we get? 1.09 will do. When x is negative 10, I get 1 plus negative 10 over, again, 101, because negative 10 squared is positive 100. And what do you get? 0.99, I think. 0.91. So it'll actually be 1 minus 10 over 110 over 101. 0.9, etc. Girls, the x is 10,1 is from above, and the x is negative 10,1 is from below. Now, the only way that that can happen is as follows. The x is 10,1 is from above, so it actually has to go like this. And the other one is from below. Now, does it ever touch down here? No. I know it's a bit weird, but this type you won't be asked till year 12 because you'll learn how to find the turning points. But difficult to know what happens to the curve. When we do differentiation, you'll learn where it does turn. But at the moment, you could just substitute some values. When x is 1, y is 1.5. When x is 2, you've got 1.4. When x is 3, if we have a quick look, you get 1.3. Okay? If you substitute it there, see it's coming back down. All right? And then you could do the same for -1, -2, and you'd find that that would happen the other side as well.